Hello, everyone. Good evening. Welcome to today's sessions on the Arewa Deep Learning Fellowship, and welcome again. So last week we spoke about, or we discussed about computer vision, in which we were introduced to, in which you kind of understood how images as a data set, how a computer understands image, and how you can build a model that will be able to process those image and give very valuable predictions of what that image holds or what that task you want to solve for. So, and particularly today, we'll be deviating a bit from building models, but to a very key component that also it's very critical for building models, which is like data sets and going modular, which is like the object-oriented part of building models. So this is also very, very key in it's a very, very key skill when you try to build models. And hopefully with the skills you get to learn, you'll be able to streamline your workflow and learn how to like use almost any data sets and load it with PyTorch and build a model from that. So this is also important, Charlie. So I'll just open up our resource we usually use, which is this by Dan Bouquet. So just give me 1 minute. So in the previous like lectures, you've seen how like we build models, but one like very crucial part of our building models is the data. So data is very, very important in anything you do with building models. So imagine in the case you have a good model but you have a bad data set. So, and I have like an average model, but a very good data set. So it's likely a chance that my model will perform better than yours because you don't have very good data. So that's why you see really like the big companies that build like models, LLMs like ChatGPT and Anthropic. So one of their best recipes is, or they focus on is like the data sets. So once you have very good data, so your model, your performance is almost guaranteed, not really guaranteed, but it will likely do well. It will likely do well compared to models that don't have good data sets. So they invest a lot. So like just an information like ChatGPT kind of models are built on like huge data sets that almost comprises most part of the internet. So like they kind of take Wikipedia and lots of other information from the internet, then pre-process it and do lots of processes. So it's very cool or very important to learn what you can do in pre-processing those data and also loading those data. But here we focus on like how you could load custom data sets because the past data sets we've been using were all like existing in the PyTorch API data sets. So you just call them and you have them. But what if you have a data set that's external, that is not existing? Yes, so we'll just briefly look into that now. So like we said, so I'll just keep some parts that are maybe not relevant. So when you try to do them or walk through them, so you'll be able to understand them better yourself. So I'll just go through the most important parts of it. So yes. So here okay, so here we just load our touch framework. So, but don't worry, these are things you are familiar with. And for the next step, we get our data sets. So the data sets here, like I said, are not like data sets that are already existing in PyTorch, in which you call like touch.datasets dot perhaps cipher 10 as we used in the last example of fashion MNIST. So these are like data sets that are very external. So imagine in the case you want to build a machine learning model to predict some, let me see, to predict perhaps the faces of people you know. Let's say you've gathered the pictures of 10 people you know, and for each person you have probably, let's say five people, and for each person you have 10 images. So once you gather that, so you might likely want to store them in a folder somewhere. So how can you convert those images into data sets? So because it's not existing in the Touch library or elsewhere. So this is like local to you and in a different format. So how can you load that? So that's our focus here. Then there's one question. So can I generate synthetic data sets for my use that can be good for real world data sets? Yes, so synthetic data sets are huge. I are used in like almost all modalities. So it can be images, can be audio, it can be text. So it can interest you to know like some data sets used by LLMs are synthetic data sets. So for images, you can also do the same. So how synthetic, just for information, how synthetic data sets work is you have like a framework that looks, let's say you have a very few data sets, perhaps let's say 100 or 1000. So you have like some kind of frameworks that loads that data set and check what's the distribution of that data set. Then it kind of samples from that distribution. Then it gets you like some kind of new images of that data set. So we would later see some data augmentation, but these are not synthetic data sets. So, but they are used to help the model learn better. So for this particular uh session, we're looking at some food data sets. So if you're like me and you like food, so this is for us. So this is the standard data set is from this website here. Let's see. So yes, we can go into it. So they have like this data set of 101 classes, but here, for the sake of this notebook, we are just dealing with three. Thankful to the author of this notebook. So we'll just see how we can load and download that. So these are just, so for this particular like snippet of the code is just downloading data set. So I won't go into details of that. So you can briefly look into it and see what it does. So it downloads the data sets. Or I'll explain just a few things. Yeah. So if you are familiar with PyTorch, you have this path module from this pathlib library. So it helps you to handle like parts of your Python. So what happens here, we are just setting the part of our data set. And here we want to store any part of a data set into this folder called sushi, pizza stick sushi. So the sets of classes or images we have as images that have like pizza, steak, and sushi. So we want to store them in this folder here. So here we are just checking if the folder exists. Then here we are downloading the data sets. So here data sets exist somewhere on the internet. So fortunately it's saved somewhere else. So it can be on your local directory. So then you don't need to download it. So here you are downloading it from some cloud resource and bringing it to local so that you can load it on your PyTorch. So that's like majorly so here it's like it's saved in zip. So you're unzipping. So this is just like additional so not like the key part of what we are focused on. We just want to download the data sets. So here it's telling us the data sets exists because I've run this notebook before. So when we look at it, you can see it's saved under stick sushi. And you can see it has like a train folder and a test folder. Then we can go into that and see. So for the train folder, you have like pizza, steak, and sushi. We'll come to see what are in each of this. So these are like images. And yes. So also feel free to ask any questions if there are any information you want to know, then I can explain on that. So I'll skip a few things and discuss like things that are valuable to you. So most of it are like Python and what's the name? And Matplotlib. So yes, so this is where we begin what we'll be discussing. So when you want to load a data set from, let's say that you have a local with touch, so you need this particular classes, one of which is this, like datasets, transforms, and data loader. So as we said, we've discussed about this data loader in the previous session. So how data loader works is, but we'll also look at it later on. Or rather, let me see. Yeah. So let's say you have a set of data sets. Let's see, 1, 2, 3, 4, 5, up to perhaps let's see 10. So with data loader, what it does is you specify how you want to load the data set and it turns it into an iterable for you. So what it means by iterable, it fetches the data set for you repeatedly until it's done. So you can, in this data loader, you can set a batch size of 2. Let's say my batch size is 2 here. So what it does is at each particular instance, it picks 2 of the data sets and it becomes like 1, 2. So at the very first iteration, let's say iteration 1, then at iteration 2 of the model, then it picks another set of the data here for me. Let's say 3, 4, and does the same until the very end. So that's data loader. So think about it like you are building a house and you have a laborer so that shovels sand for you. So repeatedly it will like take his shovel and shovel sand, pick it and like drop it. So that's like data load, a simple kind of example of how you can think about a data loader, like a laborer with a shovel, just shoveling sand and yeah, from one location to another location. So yeah, so the amount of sand he shovels is, you can say it's the batch size. Yes, so so there is a question by Halima. How about if it's picking 1, 2 till the end? So so do you mean like it starts picking 1, then it picks 2? So what happens is if you set the batch size, it is very constant. So, but you can repeat the question if I'm getting it wrongly. So let's say you have 1, 2, 3. Let's say you have data 1, 2, 3 up till let's say 9, for instance. So and you set a batch size of 2. Let's say our batch size here is 2. So you can see for, so you have like maybe 1, 2, then you have, let's say 3, 4, up to, let's say 7, 8. When the very last batch, you have 9. So it depends on like the size of your data set. So, but the data size is like constant across all the iterations. So, but in the very last step, so it's likely it can vary. So it can be less than the specified batch size. So assuming I have images in PGM. So there's a question by Ibrahim. If he has images in PGM format, how can I load this? So we'll come into custom. Yeah, and yeah, I will tell you, I will let you know how you can do that. Yes. So no worries. Yeah, thanks so much for the question. So we'll just move forward a bit. So this session is like mostly lightweight. So we'll be covering 2 sessions today. So, but don't worry, I'm very sure if you go through the notebook, you'll be able to understand them. Yes. So here I've explained what a data loader is. Then we have datasets. So datasets is from the Touch Vision library, so which is also from PyTorch. So what the Touch Vision library does, it has like some APIs to help you build your models better, and you don't need to build things from scratch. So you have all that. So what it has in this dataset module, so you can either load the datasets, you can load several datasets like we did in last week, where we loaded data set of fashion images or fashion images. And you can do like different things with the data sets. Then one interesting thing we haven't covered, or maybe you've seen it, is transforms. So transforms, what do transforms do? So transform tries to manipulate your data. So here we are dealing with images, so it manipulates your data in different forms. So one of which is you can resize an image with transform. So assuming, let's say you have an image of, let's say 2560 by 140. So this is like, let's say a 2K image. So you can transform this image to a lower resolution image to maybe, let's say 64 by 64 using transform. So this is like one of the very few things transform do, but it does like a lot of things. So you can transform, you can do like transform dot resize and call like the resize class, then transform this image. So there are other transformations you can do, but we'll look into that also deeply. So this is like just one key thing. Don't worry, I'll explain more about it in the next cell. Yes. Okay. So with transforms, what it enables you to do is transform images. Let's say you have a stack of transformation, an image coming in colored format, and you want to resize it from maybe color, you want to resize it first, reduce the size, maybe by the height and width dimension. And you also want to change the color, you want to rotate the image. These are several things. And you want to do them in order. So how you can do them is using this transform compose. So think about compose like a pipeline. So that pipeline, you give it a series of transforms it needs to do, then it arranges it in order for you. So let's say we have this, okay, let's say we have our image coming in, and we can have this compose here. So it's like a composition. You can think about it as a composition of several transformations. So one of the transformation you can do is probably resize. Just give me a minute. Let's say you can resize the image. Perhaps let's say this is 64 by 64. You can resize it to 32 by 32 and you still have like the image here. Resize. What you can do next is you can change it to grayscale. Then you can perhaps rotate it. So these are all under transformation. These are all under compose, and the image changes its properties. So its visual properties. So at first we are resizing, then grayscaling, then rotating, but all under compose. So compose is just like a pipeline. So I'm going to give you this image. These are the set of rules or set of operations I want you to do. So first, okay, so let's look at how it is in the code. We call our compose class and we pass it several transformation. So first here, what do we want it to do? So we want it to transform the image of any size that we have to 64 by 64. So, and again, why is this important to transform it, the size? Because images comes in various size. Assuming you train your model based on a data of a particular size, let's say your training data is perhaps 128 by 128. And I come to test your model. You built a very fantastic model that works really well, but the images is 128 by 128. And I take a picture, and that picture is likely maybe a 2K picture of 2560 by 1440. You can see these are like different sizes. And you know, with PyTorch, you need to have like the same dimensions across, like say your model, your data coming into your model. So if I pass this into your model, so it will flag a very big like error, like a mismatch. So, and we don't want that. So usually the best thing to do is to set a standard size across which your model will use. And this is where we set it using this particular uh, transformation here. So any image that comes, be it training or testing, so it will have this standard image size, which is 64 by 64, which is what we want. Then next, what we can do is transform by flipping the image horizontally. So don't worry, I will show you how the effect of this so that you can visually see it. So you transform the, oh, okay. Yes, so you transform the image with a probability of 0.5. So if you remember from statistics, from probability, you have like 0 to 1. So this is, if you 0, it's like not happening, then here it's like with certainty, with extreme certainty, it will definitely happen. So when you set a probability of 0.5, it's like in between. So you are telling it like half the time, it should flip the image horizontally. So half the time, it's just leave the image as it is. I will show you the effect of this and you see how it is visually. Then finally, you want to convert like the resulting image into a tensor, which is what our PyTorch needs. It needs like set of numbers. So numbers that are in the tensor objects of PyTorch. So what we've done here is any image that comes in, we resize it to 64 by 64 and we can flip it. And also at the end of the day, we have like a tensor output. So let me quickly, so this random flip is what we call like data augmentation, because the thing is, when you train your model on a particular data, so it's likely the data might be standardized, but in the real world, it might not be the case. So let's say you maybe take an image of me now and you train a model of several images of me like this. So at one particular instance, I might not be like this. I might perhaps be looking sideways. So, and your model will not get to understand that. But once you try to do like this flipping or any other transformation, so your model will have like a wide distribution in which it will learn from. So I'll just quickly show you. Yes, see. Just give me 1 minute. Uh, just give me 1 minute. Okay. So in the meantime, um, Yes. In the meantime, I think there's a question. Then I show you part of the illustration. Just give me a moment. So the question in which, yeah, from AUST, does rotation help in learning? Yes, rotation helps in learning. So like we said, because you really don't know how the test images will come from, because in training, it's more of a bit control. Like all your data sets, you can get it from within like some controlled settings of your images. Maybe there are pictures of persons, so likely they might be like just passports or something. So you can see everyone's aligned and the face is exactly looking at the camera. But in the real world, people might be looking different directions. So rotation helps a lot. So just to make sure in any variation of data that comes in, it can easily understand it. So there's a question from Tenimu, does the compressing or resizing the image affects the quality of the model? So when you resize the image. So there are like bits of like trade-offs. So, but by compressing, I'm not sure what you mean by compressing, but resizing, when you resize the image, so the input of your model is smaller. So you have like a smaller neural network and you don't need as much compute as you need as when using a very large size image. So yes, but maybe you might have like a downside in which your model might have if it's if it's resized really small, so your model might not really understand like the underlying because some things might get missing. So imagine the image of me you are seeing now, which is likely, I'm not sure, maybe 180p or 2K, and let's say you try to resize it to a much more lower resolution, perhaps maybe the most simplest resolution, let's see, probably like 2 by 2. So it's likely towards the, I don't know, top right, you might see something whitish, and towards the like bottom, you might see something ash. So it loses its meaning with time. So you might want to be careful with like resizing and don't resize too little. So, and I think one thing of note is when you are dealing with some what's the name? Already pre-trained models like the AlexNet or ResNet. So they have a limitation of like the input. So it might not go lower than either 64 or 32 because you do some convolutions, which reduces the size. So you have to have some above some particular threshold. Yes. So I'm just going to show you the illustration now. And yes. So one of the illustration you can see for, which is also relates to your question also. So you can see this image of this astronaut here. So you can see here, this is the actual image. And once you try to perform some resizing of the original image across different scales, then you can see it kind of changes. So this is like the, so this is the resizing by 30 by 30. So from the original image, you want to go 30 by 30, which is the lowest resolution. You can see it kind of loses its meaning, even for us as humans visually. So, and some things might not be clear at the end of the day, but if it's a very simple task, your model can be able to understand and do it. But if it's a very complex task, let's say of image segmentation, becomes quite difficult. So you can see how it becomes finer and finer with as the size increases. So you can see by the original size, it's exactly as the first and the last one. So there are various transformations that you can do. You can resize or crop. And yeah, we'll look into it in depth better. So yes. So there's a question from Abdul Hamid. Is there a side effect to using augmentation? Yeah, thank you very much. Bala has answered. So yes. Okay. Yeah, so I will just skip this. So this is more of like the effect of what the transformation does. And so hopefully when you go through the notebook, you're able to see them better. So, so one, as we said, like custom data sets. So we've downloaded these data sets and we can transform it. So, but how can we load these data sets? So from our local disk into PyTorch. So one kit, there are two ways to do it. So if your data set is already in a folder and it's well organized, as we can see in this particular format. So all our data set is under this, just give me 1 minute. So all our data sets under this tick, and you can see for the train and test, we all have this like really nice subdivision for a train set and data set. So for our train, we have the three classes. For our test, we have the three classes, and each, you can see here, it's like, it has a very clear and neat structure. So for this, if your data set has a very clear and neat structure, so in which each of the folders here represent the class, then immediately you can use this image folder, which has been provided for you by Touch. So we'll just look into how we do that in a minute. Okay, nice. So what we would need to do, so from our data sets here, so it exposes a class called image folder. And what we will need to do is like we pass in the root directory of our train directory. So which is the directory of this, of our training set, which is this. So we pass it into it. Then, oops, let me see. Okay. Then we pass in our transformation. So what it will do. So remember we said it will resize, then it can flip horizontally and also transform it to tensor because the image it is loading, it's likely a different format, which is probably .jpg. And I'll also come to the question about like using PGM. So you will also see how we can do that. So what we did for the train, you can also do for the test the same way. Then we pass in the test directory and the transformation we can make to the directory. So immediately after doing that, let's try running our code and see. So it gives you some high-level information of what is comprised in the data set. So it's telling you there are 225 data points for like the train and the composition. So that's one way to go about it. So, and you have information about like the classes available, then the index of the classes. So that's it for image folder. Then yeah, I'll just skip a few things here. So the rest of the things are things you can see on your own while like working with the notebook in Shano. So yes. So now that we have our data sets, so we can pass it into the data loader. So we've explained what the data loader does. Just think about like a labeler that learns to pick your data for you at every iteration and pass it into your model for your model to learn. So you can pass in, we've talked about having this batch size, number of workers, and so I will just explain number of workers here. So think about it still the same sense of having laborers, where a laborer will pick a data and pass it to your model. So instead of having just one laborer, you can have several laborers. So as much as you can employ, but this depends on the capacity of your computer. So if you have or the capacity of your machine. So if your computer has like several, perhaps cores or several processors, then you can specify the number of workers. So the higher the number of workers, that's like the idea of like more laborers you have. So the faster it is for you to load your data and pass it into your model, and your model can perform much more faster computation. So yes. Then here again, you have shuffle. So what shuffle is, it's a flag that should you shuffle your data? Should you rearrange it or as it is in your data in the same sequence? So let me just see. So you can see our data comes in this particular sequence. Maybe you have this image in this numerical order. So what shuffle is saying, do you still want it in this order? So, or should we reshuffle it? So here, as we set it to true, it's just denoting that, yes, we still want, yes, you can like shuffle the data around. So just to introduce some kind of mechanism for much more better and much more efficient training. So, but for testing, you don't need that. You don't need that because your model is already trained. So if you shuffle your data or not, so there would likely be nothing to add to the model. So yes. So, and you can think about shuffling in the sense where if you don't shuffle your data, maybe in the very first instant, what your model is learning to predict is only, let's say, pizza, for instance, and your model can just fool itself to always predict pizza in the very first few runs. But if you shuffle it, it will see pizza, steak, and yeah, I've forgotten the other class. So it could just see like different variations of them and then to predict them effectively. So yes. So I'll just briefly go. So that's majorly it about custom data sets with the image, but I'll show you the second version, which relates to one of the questions about PGM. So yes, so here you can see you have your data set Here we're trying to load the very first batch here. So, this is for the very first image loader. So these are where you have like folders clearly defined. But in the case where you have some data sets that is unstructured, so in the sense unstructured means there's no really clear format or the files are not stored as you have in this directly or in the neat format. So one example is that I can tell you is, let's see, I give you a data set and that data set is in a .csv format. We all know what .csv is, right? Comma separated values, or let's say it's in a text format. And in that text format, what you have is this. Maybe you have maybe an index, then I give you the class name, then I give you, what's the name? Maybe either a link or some directory where that file is. So this is maybe 1, 2, 3, and this class can be either numbers or letters. So let's say we are trying to predict some perhaps plants. Let's say maize. This is cassava. This is perhaps rice. Then maize again. Then continuously. Then I give you some directory. Maybe it can be a local directory or a web link. Maybe www.xyz. Then maize 1. So as you can see, maybe .jpg. As you can see, this is just a single file, but this file like, kind of links you somewhere else. So it can be a directory or a link. So, but this, you can't directly use image folder in this particular sense because it won't work. Because like we said, image folder requires a very clear structure. And with this, you just have one CSV file and that gives you more information about what you want to do. So in this particular case, you want to use what we say custom data sets. So with custom data sets, you inherit from the original dataset class and you tell it what you want to get from this data or information. So it can be anything. So yes. So yeah, I'll get back to you. So there's a question from Halima about the number of workers. So, but I'll get back to you just at the end of the class. Just remind me. Yes. So yes. So let's say you have this format of data, and instead of having like several JPGs as we saw that we downloaded, we just have one file, and that file kind of relates to several other files. So how would you load this? So you have to use custom data sets for this. Then I'll show you how we do that in a minute. Let me see. Yes. So here we just load the necessary libraries, then yeah. Yes. Just give me, yeah, I'll just skip this. So these are things you can check through yourself. So I will just go through what's more important for you here. Yes. So here, when you want to create data sets or custom data sets, so what you have to do is you have to inherit from the dataset class. So, and you kind of tell it how you want to load the dataset, any dataset that you have. So you can call it by any name, but first you have to inherit from the dataset class. And 2 or 3 things are important when you do this that you need to set. And one is very compulsory. So we have what we call like magic functions, so that you need to override. So this exists in the original dataset class. So first is this data item and length. But I'll tell you what it does and you will see it. And also I will relate it back to the question. So just to take you back a bit to your OOP. So first you set a class and you like initialize. So this can be anything. So anything you want your class to hold when you instantiate it. So here what we are trying to do is maybe our data set is stored in several parts and we just want to have all the parts of the data set. Then here is probably transformation you want to perform on the data set. But this is just particular to this notebook. So when you load you don't need to do transformation in this case. Usually you do it when okay. Yes, you can do transformation in this case. Then here's like any transform as we have described already. Then finally, not really finally, then this can be like the class names and the class index. So here there is a function that gets the class name of the class and class index, but we didn't look into that because I just wanted to show you what's really important now. So then you have this function that loads the image for us. We pass in the index of the image, then looks through the paths, then loads the image. So this not really, so it depends on what kind of image loader you want to do. So here the idea is we have a list of images, let's say 1, 2, 3. Let's say this is image 1, and we have like the path of the image, maybe .jpg image 2.jpg. So here what we are trying to do, we have this as a Python list. Then here we are just trying to get the image object in this load image. So by the image object, I just mean by, it can be anything. You can use anything to read the image. So it can be either, let's say, matplotlib or the popular PIL library, which is used here. So this image.open uses this PIL object. So just like get the instance or object of any image you want to load. So next is, so this like init and load, it can be anything. So you want, so next, which is more crucial is this dot length, which is, it's not really compulsory to have this dot length, but this is much more compulsory. So you want to get an item from the data sets. So like we said, you have, it can be a list or CSV, and you have the image link. So you want to get an item from this. So this is where, which is important. So you can have several other functions like this load function to get the image for you. But here you need to set this. So here is just, we load the image and you have the class. Then at the end of the day, we return an object of the image here. So, or image or tensor, anything you call it. Then if you are doing supervised learning, you know, supervised learning, you have the data and the label. So you need to have the data here, then the corresponding image. And if you have a much more complicated data that you need to return several other things, or maybe you can have more than one label. So you can be like, if you are doing perhaps segmentation, you can have the image, the label, then the coordinates of the label. So it can be anything actually here. But what's more important is to have this get item just to receive a single item of your data set, and length here to get the total size of your data sets. Just for information purposes, but it's optional. So you can have any of that. So those are like the key main things. So there was a question by, if I remember, by Ibrahim about PGM format. So if you have an image in PGM format, so instead of having this image.open, so it's possible, let me see. So it's possible PIL supports PGM, but I'm not sure. So, but if you want to use PGM, so you can take any library that uses PGM, then you can load it here by passing the path. So hopefully you get like the image object and you can manipulate it the way you want. So that's majorly it. So if it's confusing at any point, just feel free to ask question. Happy to answer now or later. Then we can discuss more about it. So yes, because some data sets you come across, because if you are like dealing with, you don't want to do some massive pre-processing and make sure every file is in the folder that it needs to be, then you can just have this custom data sets to help you make things better. So I'll quickly run over a few things. So those are like key things. So, and most other things we've explained, then just to give you an idea. So there are lots of transforms, and there's this website we have looked into, yes, this illustration of transforms. Then you can see how there are like various varieties of transform and you can learn to play around with it. So quickly, we'll just talk about some. So one other transform you can see is this rand augment. So what it does, it applies like several transforms randomly. So it can be horizontal, it can be vertical or flipping, like in a random order. So they've shown that it helps you to improve the quality or the performance of your model. So you can just check out. So I guess this link is broken. So, but what you can do, you can just Google it. So likely they change the link. So if you want to perhaps contribute, you can, I think this is the, yes, I think you can see the original link. This is the original link here. So yes, so if you want to contribute, you can look at the original repo and make a push request for this. So I think it will be valuable for other people so that it will be easier for them and not get stuck. So yes, and yeah, so quickly I'll just go through. So here they've done a training and compared the performance of the model. So, but you can look into that. So we've discussed about this, about how you can train the model with the CNN. So I'll just discuss some very few concepts. Just one more thing. Yes. So this. So let's say you have built a model and you've trained it. Perhaps you use some custom data sets or some existing data sets that's really good. So how can you evaluate your model? How good is your model? So there are various ways to do, or some three terminologies to look at it. So one is underfitting, overfitting, then just right. And you might have come across it in this and machine learning, but I'll just briefly go over this again. So underfitting, what happens in underfitting? So underfitting is the idea you've trained your model and you've tested your model, but the results don't just make sense at all. Your model has not learned anything, both in training and testing. So you can say it's like dumb. So yeah, so you can see like there's a very huge gap between the loss it can attain, or even though you don't really know how low it can go theoretically. So you want it to go as low as zero, but you can see like your train and test, they are not making sense. Like they have a really large margin away from what's really possible. So here you can see like a very huge gap here, and the performance are not good. So this is based on the test loss. So, and when you look at perhaps like other metrics like the accuracy, maybe you can be getting some really low accuracy of probably 30% and maybe 32%, something like that. But you know it can go higher than that. So you can say your model has underfitted. It has learned nothing from your data set. Then one other thing is overfitting. So overfitting simply means your model in training has memorized the data sets. So it performed really good here. So it has performed really low as possible. But when you try to test the model here, there is like some deviation. So when you test the model in the real world, it doesn't really work as good. So you can think about the scenario of a student studying for maybe an exam or something. So if it's anything in the material, it can like give it out really well. But when you go out of scope, then it becomes difficult for the student. So you can think about it in that kind of terminology. Then when it's a good training is when your test and training almost like kind of overlap, not really overlap exactly, but they kind of go low in the same trend and they are quite similar in nature. So that's when it's just right. So yes, so that's majorly it. So quickly we'll look at some other aspect of uh, going modular here, but feel free to ask your questions. I know there's a question I skipped, but I'll go over it again. So the idea of going modular, it's more towards like the OOP side, which is object-oriented programming. So when you do object-oriented programming, so you want to learn how to reuse your codes as much as possible. So just a brief, let me see. Yes. So in OOP, we have functions or classes. So can you briefly, maybe you can type out what's the difference between functions or classes? So that I think we can start from there and just in the next like 10 minutes and we can discuss about going modular and see how it's important. So just feel free, there are no wrong answers. So you can just as short as possible response. If you want, you can also unmute yourself and you can just talk about it. So between functions and classes, what do you think are the difference? anyone wants to take a stab at it? Yes, so let's see. Okay, I think there's a comment by Khadija. Classes uses multiple instance and functions don't. Nice, really nice answer. Thank you so much for that. And yeah, so with functions or classes, why this is important, I'll go over it in like deep learning. So typically, like in functions, what you have is, I mean, programmatically, you have this def, then perhaps some function name. So what you want it to do is just perform, how like, just to do an action for you. And in classes, you want it to store some data, and also perform an action for you here. So with going, the idea of going modular is like when you know the function, the how will I put it, what this tool does. So it's easier for you to restructure your code into something you can reuse always and always and always over and over again. So it makes it very, very easy. So, yes. So I think going back to Khadijah's point about like how classes having multiple instances. So when you think about like building your model, so when you try to build your model, remember you kind of have this class and you have the name of the model, then you have this nn.model, then you have this init, then you have this forward here. So here you can change the architecture of the model as much as you want. So this architecture of the model relates to like the data. Then the action it performs is like in the forward function or anything. So what this helps you to do is at any point in time, you can create several different models or different instances of the model, and you can use them over and over again. So that's like one of the ideas of going modular. Then with functions, anything you know you would want to reuse over and over again. So instead of having it in just one code block, then put it as a function, because it will help you in your code at that particular instance and in the future, so that you don't need to rewrite the code over again, and it helps you avoid spaghetti code. So your code is very, very well structured. So general idea is anything you use over and over again, and you put it in a function. So let me just see if there's an example here. So there's also a comment by Alfred and Naziru. Thanks so much for the comments. Let me see. So yes. So, but hopefully, if you go through this particular like Markdown file and you read through it, you understand it. So, what are the things you could make modular? So, one of the things you could make modular is your perhaps how you load your model, how you load your data sets, or let me see, or your training setup. So you can see initially how you typically train your model is you have this maybe for loop epoch in perhaps 100, and you kind of look through your model, you do like the forward, you do the backward, then you do like the step, but you try to run this like several times. So if I give you a new model, so you have to rewrite this over, but imagine you put this in a function here. And when you have that function is train model, so anyone seeing your code, it knows what this is going to do. And anytime for you also, it's a very good reference. So you can move it around and you can export it or move it to, or push it as a library for yourself in GitHub and easily utilize it at any point in time. Yeah, so because when you try to like work with people as much as possible, then you have to like standardize your code into with some, yeah, you have to like kind of standardize your code so that anyone reading it will be easier to work with, and even for yourself it will be easier to like implement and extend more on that. So yeah, so that's majorly it about modularity. So just making things as small as possible, and it simplifies your workflow. So hopefully when you go through this, you'll be able to see what actually is modularity, but the high level concepts I mentioned are quite important with, let me see, I think I've cleaned it. So yeah, so with functions, anything you do over and over again, put it in functions. So if it's classes, anything that stores some data and also perform some action, you put it in classes. So hopefully it helps you. Then I'll just quickly go over some questions that I missed. Let me see. So there's a question by how can you about the workers? So briefly in the last few minutes. But if you have any questions, you can ask them now before the final 4 minutes. But this is like majorly part of it. So workers, think about workers in the sense that, okay, let me see. Okay. Yeah, so let's say still you have, let's see your data here. Let's say you have D1, D2, D3. So I don't mind the size D4 and perhaps up to D100. So let's say you have just one worker, and what you want to do is move from this data from here to perhaps your model, just so that your model will learn. And when you have one worker, so what the worker does is first it takes the first data and moves it to the model, it takes the second data, moves it to the model, third data, and so and so and so. So assuming it takes 1 second for your worker to move the data, so it will take you approximately, let's see, your number of worker is 1. So it take you approximately maybe 100 seconds, assuming. It takes 1 second to load each data point. But again, let's say, let's see, 1 minute. So let's say you have several workers. Let's see, worker 2 up to perhaps worker 5. So each worker can independently take a data that it wants. So worker 1 can move data to like to the model, and at the same time, in parallel, worker 2 will perhaps move this data up to worker 5. You can see they've kind of cut it. They've kind of cut the process by 5-fold. So instead of having 100 seconds, let's say in the instance where you have 5 workers, then your T will be like 20 seconds. So it's faster. So depending on like the number of workers you have, but you need to make sure you have them available. You have the number of processes available in your computer, because if not, you overload your computer and your loading process will crash. So you need to make sure of that. So yeah, so that's majorly about like workers. So, okay, I think, yeah. So I'll just wait 1 more minute if there are any questions or comments. And yeah, so finally, in the meantime, so yeah, let's see. Yeah, so just again, a
Okay, sir, can
recap.
I ask?
Yes, feel free.
Ah, all right, typing will take my time because you said just 1 minute.
Okay, no worries.
So if maybe let's say worker 1 take the first data set to the model, and then worker 2 take the second data set to the model. So is the model will process the 2 data set at the same time, or it has to wait for the first one to finish, then process the second data set? How does it do that?
Yeah, so it depends on your setup. So if, so let's say, I would say, so the processing of the data happens, let me see. Yeah, so what happens is, so I guess it's kind of confusing when I say it will take it to the model. So before it takes it to the model, so actually not the model, because you remember we have like, let's say your data comes in and you have some transformation. So instead of the model you explain, just permit me, think about it as the transformation we talked about. So each worker will perform a transformation. So it can independently like perform the transformation, then combine everything together. So you have perhaps some new like reformatted data sets. So instead of, I think I made a mistake like saying the model. So think about it as like a transform or any other additional operations you need. It can be like loading from your local file system to your computer's memory. So you need like several workers for that. So when you have more workers, it's easier for it to load into your computer memory. That's before it starts training. Yeah, thanks for the question. I think it will help also clarify things. Yes. So you can, it's just for it to
Thank
load your data before you pass it into your model. Yes. Mm.
you so
Yeah, you're welcome. And also, it can also mean
Thank
passing
you.
it to the model. So that's where, when you try to do distributed training, so you can have several, you can apply the concept into like the model when you try to do distributed training also. Mm. So, yes.
Yeah, good evening,
Yeah,
sir.
good evening. Yes, welcome.
Yeah, so somebody asked a question about compressing. So I just
Okay,
want to make sure I don't have this misconception.
okay.
Um, when you reduce the scale,
Mm.
right?
Yes,
Um, like the intensity
yes.
of the scale, when you reduce it, does that mean you are compressing it in comparison with resizing,
Mm.
which in some sense reduces the dimension of the inner matrices? I'm being careful with the word dimension now,
Mm.
not in the sense of PyTorch. Yeah.
Okay, okay, okay. Yeah, thank you so much for the question. Yes, I think resizing the image, you can think about it like in terms of compression. So you are very much correct because when you resize the image to a lower resolution, so you're actually reducing the size of the image. So you can think about it also, you are very much correct as compressing, but a bit gets tricky. So when one says compression, so you might want to think about maybe some other approaches for compressing the model, but it's very much correct also. So you can think about resizing as compression. Then let me just go back to the question. Yeah, so when you compress the image, so like I said, there are like trade-offs. So you don't compress too much. You just want to compress to the just right amount so that your model will still able to understand the information or some features are available to your model. So because like looking at it even for humans, when images get to a very really low resolution, so it's difficult for you to kind of grasp what's underlying within the image. So most times we tend to go for things that are like really high resolution. But when training your model on large really high resolution comes at a cost because you are dealing with a larger size and you need much more capacity or your model needs much more compute to do that. So it gets tricky. So you want to have a balance between not much of resolution and also not too low of a resolution, but still good performance either way. Yes. Thanks so much for the clarification.
Thank you.
Then yes, I think there's a final comment briefly about Ramadan. Yes, so I think I wanted to talk about this. So yes, Ramadan is approaches. It's approaching. That's the fasting period. So we'll still go as intended, but there'll be a change in the schedule. So hopefully in the coming weeks, you'll be updated, likely within this week. So the session will change from evening, I believe from next week to a morning session. So it will be a morning session, likely around 10 or 11 a.m. in the morning, but you will be specifically told about this beforehand. So we'll have 3 more sessions after this, and there will be like 2 weeks holiday before you start your project. So in that 3 sessions will go over like the last bits of the PyTorch, which we'll be finishing. Then after the holiday for 2 weeks, you will be starting your projects. So and one reminder, so all the details about the dates and the timing will be sent to you via email and Discord and Telegram. So one reminder is to really make sure you submit your assignments, weekly assignments as possible. So we are rounding up the feedback for week 3 and 4. So because if you don't get to submit those assignments, so unfortunately you won't be able to like do the projects because we want to match people that are really serious about the assignments in groups so that they can do the group work. And so just make sure to do the submission as fast as possible or as much as possible. If you have any questions or difficulties, we are always on Discord. We'll be able to assist you as much as possible, inshallah. So yes. So I guess that's majorly it. So if you have any questions, just feel free to send a message on Discord. Happy to talk to you anytime, inshallah. Yeah. So yeah, there are comments on not yet getting assignment feedback. So please send a message to us on general Discord. Please, you can kind of what's the name? Reference me and Bala. So we look at it together, then we see what's possible. So because there are lots of like assignments or lots of people to grade, and the TAs are really doing a really good job trying to grade and give feedback so that you can work on it and become better. So just reference us just tag us on any of the Discord message and send us a message. So we'll be able to assist you. Yeah, I see a few people. Just tag us, me, Bala, or any of the TAs. Then we look at it. Then tell us specifically, tell us your name, then which week assignment have you missed or anything, or you haven't received feedback for. Then we get back to you as much as possible. So I'm guessing probably no one has received week 3 feedback because we are still in the process of compiling everything. So hopefully within the new week, you'll be able to receive like the feedback. But I think for others, try to complete the assignment as much as possible. So because it will help us gauge what you've learned and help us like pair you with your teammate for the project so that you have a very good experience for the project. So I guess if there are no questions, I would say that's majorly it for today. Thanks so much for joining and for the questions and the insightful comments. I really appreciate it and had a good time about it. Yeah, thanks so much. So if you didn't get feedback on the assignment, send us a message on Discord. Yes. Yeah, have a wonderful weekend and rest of the week.